See the question. Show that the function f from r0 to r0 defined by f of x equal to 1 by x is 1 1 and on2 where r0 is the set of all non-zero real numbers. That means 0 is not there. Is the result true if the domain is replaced by n? Okay, here the domain r0 is there, right? If you replace this domain by natural numbers, then you need to check whether the function is 1 1 or onto. Okay, see, I'll take the first function f from r0 to r0. That means domain of this function is equal to real numbers, but 0 is not there. And what is codomain? That's the second set, right? Codomain also equal to r0 is given, that is r minus 0. That means 0 is not there. Now take the given function f of x is equal to 1 by x. Okay, generally you are taking f of x as y, right? Because image of x under f you are taking it as y. Y is equal to 1 by x is given. Okay, clearly see, x is not equal to 0, domain is r minus 0 is given, right? If x equal to 0, then function is not defined. First check the 1 1 condition. For that reason, take two elements x1 comma x2 from the domain. What's the domain? Domain equal to r minus 0. Okay, now see, take f of x1 equal to f of x2. Okay, if images are same, then what you have to prove? That the elements are same, right? You need to prove x1 equal to x2. F of x equal to 1 by x, then what is f of x1? F of x1 is equal to 1 by x1 equal to f of x2 means 1 by x2. Cross multiply, x2 is equal to x1. This implies x1 equal to x2. So images are equal, then elements are equal. What it implies? F is 1 to 1. In the next step, see, you need to prove the onto condition. For that reason, take y belongs to codomain. What is codomain? R minus 0. Okay, what you are proving in the onto condition? Here set A is there and here set B is there. Okay, what you have to do? Every elements of set B has pre-image in set A. That you need to prove, right? You need to prove every element of set B has a pre-image in set A. That time we say that that function is onto. Okay, that you need to prove. Okay, here what is A? A is r minus 0, all the real numbers other than 0. Here also r minus 0. That's a given data, right? Okay, now see, y belongs to r. I am taking any one general element. Okay, here suppose y. So infinitely many elements are there. I am taking one general element. That may be rational number or irrational number or natural number, because here real numbers are there, right? Okay, take that y from the codomain. Okay, then see, we know y is equal to 1 by x. You defined, right? F of x is equal to that image in the form 1 by x. Because see, we defined y is equal to 1 by x. F of x equal to 1 by x. What is a y? Meaning image of x under f is equal to 1 by x. If you take any element here, okay, from the set A, image must be in the form 1 by x, that is y. Okay, now see, y equal to 1 by x is there. Okay, then see, cross multiplying, you will get x equal to 1 by y. To prove onto condition, you need to just check whether to prove onto condition, check 1 by y belongs to r minus 0 or not. Here you can say that x equal to 1 by y belongs to r minus 0. Why reason? Because see, x equal to 1 by, what is y? Y is taken from the real number system. So you will get 1 minus real numbers. What is 1 by real number? It's again equal to a real number, right? That time what you will get? X is a real number. That is our domain itself, right? See, domain equal to r minus 0. It's a real number other than zeros. Okay, Here also I am considering real number minus 0 only, that you need to remember, because in the codomain we can't find 0 because r minus 0 is defined. So x is in the form, that means elements of A in the form 1 by real number. We know 1 by real number is equal to real numbers only, right? That indicates x, that is pre-image, that is in the form 1 by y, belongs to the set. This implies your function f is onto. Okay, for any element y, general element y, you are finding free image in the set A. So if free image is there, that time we say that function is onto. Okay, therefore f is both 1 to 1 and onto. Okay, first case solved. In the second question they given as, if domain r naught, okay, that is r minus 0, is replaced by n, that is system of natural numbers. If you change domain by the system of natural numbers, then you need to check whether function is 1, 1 and not. So I will take function f from n to r naught. Okay, domain is equal to only natural numbers. You know, right? Natural numbers means 1, 2, 3 up to infinity. Okay, there is no integers or rational or irrational numbers. Check the codomain. Codomain is equal to, what's a codomain here? You can see second set we called it as codomain, right? Codomain is equal to r naught only, that is r minus 0. That means codomain has all the real numbers other than 0, but domain has only natural numbers. Now see, take x1 comma x2 belongs to the natural numbers, that is the domain, right? Suppose you are saying that f of x1 is equal to f of x2. That means images are equal. If images are equal, then you need to prove that elements also equal. What's a given function? F of x is equal to 1 by x, or you can say that f of x means image of f under image of x under f, that is generally taking it as y. Y is equal to 1 by x. Now see, f of x1 is equal to f of x2 is there. F of x equal to 1 by x means f of x1 means 1 by x1 is equal to 1 divided by x2. Cross multiply, what you will get? X2 equal to x1, that is it's the same as x1 is equal to x2. See, images are equal, that implies elements also equal, that implies f is 1 to 1 function. Okay, check the second condition, that is onto. How to prove onto? If domain is there and here codomain is there. What's the domain? Natural numbers. Codomain r minus 0. Okay, take any element, general element from the set B. Okay, then check whether free image exists or not. Okay, if you take any elements here, then suppose you are taking one element y, then you need to check whether free image of y is there in set A or not. Okay, then see, I am taking, let y belongs to r minus 0. Okay, the second set, right? You are taking one element from the codomain. Okay, then see, we have y is equal to 1 by x, substituting the value. Okay, then cross multiply, what you will get? X is equal to 1 by y. Check whether x equal to 1 by y belongs to the natural numbers or not. Here I will write it's not belongs to natural numbers, because see, suppose y equal to natural numbers. Okay, in the domain, in the codomain y is natural number, then see, what is x? You will get 1 by 1. Then x equal to 1 by 2. 1 by 1 equal to 1 belongs to n. Okay, that is proved. X equal to 1 by 2, it is not belongs to n. That means if you take y value in the second set C, if you take y value is equal to 2, then what's the value of x you are getting? 1 by 2. But natural number, right? In a natural number there is no 1 by 2 or 1 by 3. Natural numbers, we can't find numbers in the form p by q. Okay, therefore see, your x not belongs to n. That means we can't find this pre-image in the domain. Or see, I am taking set b is there, right? Here I am taking root 2, y is equal to root 2. Then what is x? We defined x equal to 1 by y. That implies x is equal to 1 by root 2. That is not belongs to the natural number. We can't find this pre-image in natural number, because natural number means 1, 2, 3 dash 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 dash. Okay, see, if it is onto means, if you take any element from the codomain, there must exist one pre-image in the domain, that is natural number. But here your codomain is the whole real number other than 0. You can take any number. Suppose I am taking y is equal to one element here, root 3, y equal to root 3. Then what's the value of x? We know x is equal to 1 by y. That implies x equal to 1 by root 3. Okay, but x is a natural number, right? If root 3 is given, what you have to get here? 1 by root 3. But 1 by root 3 is not belongs to natural numbers. We can't find 1 by root 3 or 1 by 3 or 1 by 10 in natural numbers, right? If you take elements from the codomain, we can't find pre-image in domain. Okay, that fails the condition to definition, right? What's the meaning of onto? For every element of codomain, for every element in the B, you need to find one pre-image in domain. Then only we say that function is onto function. But here see, you are taking one element y from the codomain here, but you are not finding pre-image in the domain, that is in n. Therefore your conclusion is f is not onto. Okay, clear? If you replace domain by the natural number system, then function is 1 1, but function is not onto. Okay, this is the answer for the given question.